Okay, let's wait for 2 more minutes, then we will continue. Okay, so I think we should start anyway. This is the first part we have done. I mean, we have seen how to draw a triangle, right? We know the rendering pipeline behind it. I mean, so we know all the background theory, and we have seen this rectangle. Now we need to go to the second part. The second part is the texture. So for today's lecture, what we do first is we will create a new project which contain all of this without all these things which are commented out, because we need to clean the code. Once we create the texture, we will see we need to replace a lot of the code. Okay, so that's what we need to do first. Then we will go through some of the theory about texture first. After that, we will create our own texture. Okay, so first thing, let's create a new project and still drawing this thing. Yes, but the only difference, we just delete all these things. Okay, I do recommend you to create a new project rather than just delete it here, because later on when you review the project, you know, okay, I have done this, and how I go through here to here. So this is more like a step to step. So you know how you get from there to here. Now what I suggest is create a new project and do the configuration again. So it's a great chance you can review all the things you have done. And do all the settings. Just do it again. Configure the OpenGL. Just create a new project and make it work. and do all the settings. Delete all these things which we commented out, so the code will become very neat. After all this deletion, you will find we will have a very clean code. So we will start from there. Clean, clean, yes. Rest folder, copy and paste here. And the shader folder, shader file, copy and paste here. Now we can close this previous project. And for this one, add rest folder, group reference, and here, and one more thing, shader, paste here, create groups. Here it is create groups, add to target. Once you finish, you should be able to draw this rectangle. Yeah, the same rectangle we have seen. But now we have a very clean and neat code. Less than 100 lines of code. Looks great. Okay, so this is the first step. Please finish this. I will give you like, I think 10 minutes is enough. Make sure you create a new project and make the project work. Okay, so I think most of you should already create a new project. In that case, we can continue our course. Okay, so first, let's see one thing. Let's open the shaders, the fragment shader. Previously, we have saw this. We will be told this is alpha. Alpha is controlling the transparency, right? And we set this 1, so it's opaque. But what if we set it to some other value? Let's try 0.5 and see what's going on. If we try 0.5, the color won't change. Still the same, right? What's happening here? Why it doesn't work? It is because the OpenGL handling the transparency in another way. It handles the transparency in some way called a fixed function. So if we want to have this transparency, we need to enable GL blend. And the GL blend function should be like this. So we need to bind them together. Blend all these colors. And for the blend function, we use 1 minus source alpha. So source alpha is what the alpha looks like. And 1 minus is the rest of them looks like. So some of you just draw in, and what we did here is we create a new project. This is not the old project. So if you see, all these things have been commented out, has deleted. Now this is CG2, not CG1. And for CG2, we create the same thing as we did in last time. This rectangle, but this with some alpha value. So this is transparent. No, it's darker because it blend with the green background, so it's darker than it seems to be. Okay. Okay, once we have seen this, we will need to go back and see some of these textures, the theory behind the textures. First, Yeah, I need to make sure at least some of you have already created the second project. If yes, just let me know in the discussion area. Have you created this? And see this rectangle. I need to check how many of you have seen this. If there's some error on your screen, show me what kind of error it is. Okay. So let's try to fix all the problem here before we go to the texture part. If you cannot see that square, there will be big problem because we cannot show you how to see the square or see the texture. Okay, so anyway, I need to start the texture part. Do remember, when we come back next after the holiday, I need to check your homework. So for the homework, we will have some Tencent meeting, and in the meeting you can share the screen with me, okay, and show me your homework. If you finish that, you need to show me your homework. Okay, so let's see some theory behind it, behind the texture. Okay, so here is thing, texture. So first thing, what is texture? And what is texture coordinates? You might have heard the texture coordinates a lot. But what is texture? And what is texture coordinate? Actually, texture is just a picture or how it looks. When we draw the shapes on our screen, we draw the triangle, right? And all the shapes are just a lot of triangles, and which we call the mesh. No, not draw a square. It's draw a square, but the square is changing the color. Okay? So, when we draw these meshes, we want to map our textures on. So how to map our texture? We need to use the UV coordinates. So with these pictures or these textures, we map to this robot. Then we get this. This is how we get this robot using this texture. Okay. So here are two things. First, what is the image? And second, what is the UV coordinates? Okay. So first, let's look at the image. Basically, the texture image has two parts. Has two different kind of image. One is compressed, the other one is uncompressed. So for example, the BMP file, which is Windows-based file system, on this file, this is uncompressed. The image stored in this file format is uncompressed, and all these first 40 and 54 bytes are informations about this file, like the width and height. Okay. And there are lots of different uncompressed image file. The most often used two image file are PSD file and TGA file. Those two files are widely used. Okay. And next is JPEG file. JPEG file is a compressed file. So we have lots of compressed file format. The JPEG, the BC, like BC1, BC3, BC5, and DXTC. Okay, they're all compressed. The texture need to be compressed, otherwise it will be great. Great in scales or great in size. In game development, the maximum memory to store the texture is 3 gigabytes. This is common for most of the game development engine. So most game engine, you only allow the 3 gigabytes textures. So if you have texture more than that, you need to think about it. So that's why we need to compress the texture. But if you use a game engine, you need to import the uncompressed file and let the engine do the compression. Okay, so that's the thing. Here we just need to know, okay, all the files need to be compressed before when you develop a game, and you need to use the engine to compress file. After compression, the file size could be reduced to 1/10 of the original file. So that's great. In rare circumstances that you don't need to compress file, which, for example, if you want to create some movies or films, you don't need to compress file. You only need to render the scene. Okay, you want to render a beautiful scene. You don't want the compressed file to destroy something, because once you use the compressed file, actually you're missing some data. You lost some data. Okay, so this is image. And next, what is texture coordinates? Texture coordinate is this image. The text image, we have another coordinate system for this text image. We start from here. Bottom left corner is 0, 0, and the top right is 1, 1. So this is the UV coordinate or texture coordinate. We start from 0 to 1. This is a different coordinate system, and we use UV for this. And it's possible we have a 3D texture. So for 3D texture, 3 axes are U, V, and W. Okay. So how we map this texture image to our triangle mesh? So this is how we did it. We just indicate all the 3 vertices of the triangle and indicate what are the text coordinates of these 3 vertices. We map these 3 UV coordinate or texture coordinate to our texture image. And then the rest of it, we just interpolate. If you remember, when we draw that colorful triangle, which have a lot of color inside, we calculate the weights within the triangle. And all these weights will also be used to calculate the UV coordinate or texture coordinate. So once we have these coordinates, and we have this texture image, we can map our texture to the mesh. So this is how we did it. Okay. So there are 2 things we need to think about it. So first, if you see here, we said the texture image have a coordinate which range from 0 to 1. So what if the texture coordinate is bigger than 1? In that case, we'll call it wrapping. We give a wrapping method. So if the texture coordinate is more than 1, what do we do for the rest of the part? We can select GL repeat. Okay, so here it's like repeating all these textures. And the GL mirrored repeat is still a repeating. We repeated textures, but we mirrored the image. Next is clamp to edge. We just select the border color and use that color to fill the rest of the area. Okay, we fill it in this way. So this is clamp to edge. Another one is clamp to border. For clamp to border, we need to provide a border color. Okay, and we can fill all this area with the border color. So those are 4 options if we need to wrap the texture. I mean, all these things, we will see all these things be used for game engine. So when I open the Unreal Engine later, you will see, okay, all of this has been implemented and they can be set in the game engine. Once you know how it works and what this means, you will know, okay, so it means this, and this is implemented by this way. Okay, so next, let's do texture filtering. So what is texture filtering? Texture filtering is more like how we decide which texture colors will be filled our object, the pixel on the screen. Why was that? What's happening there? It is because we might change the size of object. Okay? So for example, we have this is texture image, and we have different sized mesh object. So when we find a pixel on the screen, we map this texture coordinate of the pixel to our texture image, and find, okay, it's here. The mapping is here. You see this black cross? This means we map the textures here. Now the question is, what color we need to return? If we return just this color, this pixel, which is nearest, we return this color. This means we will have a very sharp image. Okay, this is a very sharp image. If we return our linear combination of these four, the neighboring 4 pixels, we get this. With this weighted color, we can have this blurred image. So these two, this is all set by the filtering. Okay, so this happens a lot because it's possible you designed your models with your texture together, but in the system, one pixel might contains one small triangle might occupy a lot of pixels. Okay, so you need to decide, okay, how you render this, how you decide the color of it. So this is texture filtering. We will also see texture filtering working in the Unreal Engine later. Okay, so next, there's another thing called the mip map. You might have heard of mip map a lot. So what is a mip map? A mip map is a group of images with different sizes. So we might have the very big image, texture image, with size 0 or level 0. Actually, it's called level 0. This is the original image. Then we downsample the image, we get the level 1. And we keep downsampling the image until we cannot downsample it anymore. So in this case, there is a very specific restriction about the size. So we need the size of the image, should be a power of 2. So we can have like 512 by 512 or 64 by 64 or 1024 by 1024. This kind of image. With this image, we can have the mip map. It is also possible we can accept the texture with any size. If we have a texture which is 400 by 500, it's possible. Yeah, it's okay. We can read it and we can use it in our OpenGL and also in game design. But in that case, we won't have the mip map. So this is how we get mip map. But why we need mip map? Just assume you have a big object and you have the texture map. Okay, you have the texture for a big object. But it's possible when you design the game, when you use object, your camera is far away. Okay, so if your object is far away, what will you do? I mean, in that case, the object is very small. It's maybe just 1 point, 1 pixel on the screen. Then you need to draw the things. If you import this texture, this is huge, and you don't want it because it's huge. You waste a lot of memory and a lot of times to decide which pixel we need to draw. Okay, so in that case, we have the MIP map. The streaming system, I mean, the texture is stored in a system called the streaming system, or a streaming pool. The streaming pool automatically decides which pixel, which texture image we need to use. If you have a MIP map, it will find the smallest one, or the one which has the size similar to the object on the screen. Okay, so it will automatically use this texture image to draw the thing. Because it's small, it takes a very little memory space and very easy to calculate. Then we can have the texture, right texture. I mean, we will go through all this concept later. I mean, both in our code, in Unreal Engine. Okay. So let's have a break. So before we continue, I will send you some file, and those files will be in the let me see. Where is the file? Okay, it's here. You put the file here, the folder. First you unzip it, and then you put it here. Then we can use it. I just share the file you need to do within the. Okay, in the WeChat group, I just send you a file. Let me know when you finish this. Unzip it and put it in the file where you have this CPP file, the shade.h. You might also have the rest folder here. Same level. Just put it there. Okay, so if you done this, let's open the project and test if you did everything okay. So this is a new project we just create. Okay, so this is a new project. I mean, if you're using Windows, I mean your Visual Studio, just follow the instruction on the WeChat group. If you're using Mac, you might need to do one more step. First, let me see, copy this code. If you're using Mac, okay, this is for using Mac, and paste it here. Then drag the soil folder here and create groups, copy. So you see this soil in this color. Once you have done that, you should be able to include the header file. So try include. Let me see. I think I should write in some other ways. Okay, yeah, this way. So if you finish, you should be able to write in this way. Add this to header. As soil 2. Yeah, you should be able to see this. And there's no error. Soil 2. stb image. Okay. And if you run the code, there's no error. If there's no error, it means you made it right. Okay, you get the same thing. It means you did everything right. So make sure you can do this, then we can show you how to add the texture in it. Because with this library, we can read the image with different format. Next, we will see how the texture works. But the first thing is, we need to add the texture. We need to have the texture coordinates. Okay, so let's add the texture coordinates. I mean, I'm trying to give you enough time to finish all this coding. So first, we have okay, yeah, I think I just missed something here. Okay, before the text coordinates, let's draw the rectangle in another way. Okay, I just find out I forgot to show you how to use EBO here. So this is one way to draw the rectangle. There's another way, which called the collectivity information together with the vertices. Here float. We also have the vertices. And together we have the indices. So we want to use the vertices together with indices. On side int indices to draw the cube, a square. Okay. So vertices there looks like this. We have the position and the color. Position, we only have 4 points. We still draw the red one. Okay. So this is top right. And this is, let me see, bottom, bottom right. And this is bottom left. Top left. We only give this 4 points to draw the same square. And we can use all these 4 points, 3 to draw one triangle, and use 3 to draw another one. So the 3 points, we use the 1, 0, 1, 3, and 1, 2, 3. Okay? So now we want to, instead of drawing triangle by triangle, using this way, we can use vertices and indices. So the code looks very neat. And another reason is, if later on, if you see some big object, they're all stored in some format which only provides the vertices and indices. Or you can see something like the VT and face. So we draw the same rectangle using this. Okay, so for the vertices, we have already stored it in the VBO. They are in graphic memory. It's already there. But indices are not. That's why we need to have an indices. What we do is add here. We create a VBO and bind it. Sorry, EBO, which is short for elementary buffer object. We need to create an elementary buffer object and generate buffers 1 EBO and gr bind buffer. Buffer data. This is almost the same with how we did for VBO. Also for static draw. When you finish that, unbind it. Okay, so when you finish that, just compile these lines with these two lines. You will see they're almost identical, but the only difference is we now bind to the elementary array buffer, which is the area only for indices or collectivity information. I'm leaving the code here, so you have plenty of time to type it. Well, I saw no response from you guys. So in that case, I mean, according to my experience, previous experience, most of you might have problem here. You might not be able to finish the code here. So I just give you one additional homework. I mean, it's almost for free. It's for some of the students. If you do listen to our class, so my additional homework is show me these things. Okay, show me these things after the holiday. If you can, if you listen to the lectures, you should be able to show me all this project. So this is additional homework. I mean, if you finish that, actually you can get this homework for free. I mean, generally we will have 4 homework, and the rest 2 might slightly difficult. But now I give you this quite easy. I mean, free homework. It's like if you finish this code, I mean the code I will show you in this class, you can get the second homework. You can get the score for the second homework, and together with the rectangular one which showing changing the color, that's the third one. Okay. So I need to make sure all of you have this code. Okay, now if we want to draw these things, all we have to do is we will bind the VAO. We bind buffer, the elementary array buffer, EBO, and use another draw command, which is GL draw elements. If I copy and paste, it happens. If I copy and paste in the WeChat group, none of you will listen, and you don't have enough time to practice. You only know, okay, I just copy and paste. I mean, this is also happens for all the YouTube tutorial or other tutorial in some other university. If you check the Ivy League University, they also have some coding lectures. Uh, they study a lot, and I find this is the most efficient way. I mean, this is the best way. It's like the lecture coded in front of the student. The student just copy the code, listen to the code in the class. And another reason is this is a basic code. I mean, for the advanced part in the future, I mean, maybe in week 10 or 11, some of the code I will just show you. I will just give you post, copy and paste. Because for that course, it's more some advanced lecture or advanced part. So I can show you the code. So you only need to get the idea or the theory behind it. But for this is elementary part, I do ask you to type the code. Okay, here the only difference, we use the draw elements to draw this thing. To replace the draw array, we need to bind this first. So this is 39 we changed here in the while loop. So in that case, if you run the code, you should be able to see the same thing, right? But now we use the indices rather than the uh, drawing a lot of triangles, giving all the coordinates for the triangles. We are giving the indices instead. Okay. Okay. I just type the requirement and homeworks, so you know what you need to do in the holiday. So I go back here for a few more, 2 more minutes, and then I will scroll down. You see every part I changed. The one thing you should remember is, do you include this header file? Make sure you configure the soil in the right way. So if you include it, it means you should be make everything right. Okay. Okay, let's go here. Stay here. Okay, I scroll down. I think you might have heard we might begin the offline lectures. I mean, so in class lectures from week 9. I mean, actually that's great. So I can show you something. Although there are maybe only 10 students here, but it's okay. And we also have 1 week course called course design, right? I mean, usually the course design is it's just like give you some project and you finish it by yourself in groups. But I think that's kind of waste of time. So rather than just give you this project and ask you to do it by yourself, uh, so this is beside of this, I will use our time for the project to teach you something else, like maybe the Unreal Engine. So, so you will think that week is much more useful than just doing one project. But we will see. We will see if you have a lot of exam by that time, or if you are free by that time. If you're free at that time, I can do this. But if you have a lot of work, a lot of exams, I will just give you the project, and you finish in groups and show me the project. Okay, I know this is like maybe your last lecture before the holiday, so yeah, I will just stop here. So I give the time to you. So if you have any questions, just show me. Okay, let's go up to the beginning of the code. Yeah, we just add these two header file, and the rest of them are the same. So if you are able to include this, it means you set it right. The way to set it is just unzip the soil2 file I just sent to you, and copy the file and paste it to the project where you have the GIEW32, the DLL file, and you have the CPP file. Yeah, a same place. This is blend, which is for the transparency. If you want to have some transparency, you need to enable JR blend, and this is blend function. Okay, so that's a finish of the class. And if you have questions, just let me know. If I need to scroll up or scroll down, just let me know. Okay. First, I will stop here. I will just delete some of this so it's more compact. And stop here. Yes, I will delete this because we have already used it. From enable blend to here. Next is after this indices. Yeah. Okay, so class is over. I will close